Hello, everybody. I will start my today's coding practice. So today's coding practice is this one, minimum window substring. So I will get started. Okay, so in this question, I will be given two strings, S and T, of lengths M and N respectively, and returns the minimum window substring of S, such that every character in T, including duplicate, is included in the window. If there is no such substring, returns empty string. Okay. Returns the minimum window substring S, such that every character in T, including duplicate, is included in the window. If there is such substring, return empty string. Okay, so I will confirm my understanding first. So in this question, I will be given string. I will use this example today. And also I will be given the string T. And my task is to return the minimum window substring of S such that every character in T is included. So, yep. As shown in the example 3, if there are duplicates in the T, like AA, the window substring has to include two characters, AA. And also, what I'd like to clarify is if the order matters or not. And I will check it. And with this example, one, B, A, and C is okay, so the order doesn't matter in the charts in the window. Of the charts of the window. Okay, so that's my understanding. Let me, okay. So I could confirm my understanding. So let me get started with some example to think of the algorithm. So here, let me see. I have to find A and also B and C. So let me clarify those in the character, those chairs in this three. Yeah. And what I should do is, for example, if I start from A, I have to find B and C, and this is it. Yeah. And since that if I start from B, I have to get B, C, B, and A. Yeah. And if I get started with C, I have to find B and A. So this should be here. And if I start from here, I have to find A and C, so it and continues until this C. So in this way, I can find that B, A, and C is the shortest substring. So this I will return 4. Good. So that being said, I think I can use the sliding window. And the thing is, um, because the duplicate matters, I will first recount how many characters there are in T. So in this case, 1A, 1B, 1C. So I will, okay. So in my sliding window approach, I will think of left high index. So in this case, I will think if I finish with this A, how much I can shrink the starting point, starting index. So obviously I have to return the minimum window. I have to shrink as much as possible, which means that I should move left index as much as possible. So here, because I still haven't found B and C, I cannot shrink. So starting with still in A. However, if I keep, expanding the right index, right here, in this point, I can say this is a valid window. Then if I keep continuing to B, what I can say is I can shrink the window as long as if I throw away B or any character that is not in the T. But in this case, if I move the, yeah, if I move the left index, I will lose A, which doesn't appear in the window anymore, so I cannot shrink anymore here. But when I reach here, I can shrink the left index because I already have A. So I will keep shrinking in that way. So this is a kind of typical, sliding window approach. So yeah, let me write the algorithm now. Okay, so I can lose A, but I can't lose, and also I can lose B because it appears again. But for C, I can't lose it anymore. So this should be the valid one with the end index A. Okay, so this is my approach. So for the time complexity, it should be O of n because I have to move right index in one path and left index in one path. Yeah. So I can think of each of the index, how many times I have to move. It should be O of n. And for space complexity, I have to keep track of the counter of string t, which would take up, okay. So I will assume that the length of this is s and length of t is t. So in that case, the time complexity should be OS plus t because um, I have to make the counter of t. So I have to see each character in t to make the counter first. So that's the O of t part. And for the space complexity, it will take up to s. So for the counter, it can take up to O of s. And also for the sliding window part, I have to keep track how many characters there are in the current window, but it doesn't become more than O of S because what matters in the window, which I mean, the characters which matter in the window is something which is initially in the T. So I don't have to take care of more than length of T characters. So that's a space complexity. That being said, I will implement the code. So, okay, for three, I will, count. Yep. Um, Let me say chairs, which does matter. So then I will use the Python standard library counter. Then I will get the hash map of character to number of characters. Then I will do the sliding window. So I will start with left is 0 and I will move right. And what I should do is because I guess the new character right, I have to append it to window. So I should use counter here. Okay. So window chairs right. So I will append is the number of characters in window chairs. Then what I should do, so I appended the new character here. And the next thing I have to do is shrink the window as much as possible. But before that, I will make sure that, okay, so I will make sure that if the current window has enough chairs which were initially in T. So yeah, without that, this window is valid. So I cannot, find use, I mean, yeah, I shouldn't update the global return minimum length. Oh, and what should I return? Minimum window substring. Okay. So wait, so what should I do? Current min substring is, let me see, current min length. Yeah. Then what should I do? So the thing is I have to confirm if the current window chart includes all the characters in chart count. With me. So I think if I do if I check every car in the window, it will take a bit more time. So, okay, so my idea is I have to think every character count in the chair count is included in window chair count. So I have to traverse all the key in the chair count. They will take more time. So what I'm thinking right now is instead of using the window check count and check count, I will just use the check count. So, and I will call it something like um lock check count or yeah, missing check count. Yeah. So in this way, I don't have to take care of window check count. So I can delete it. And what I can do here is, what do you mean? But it doesn't matter. It doesn't work because if I have too much A, right? I just want only one A, but there are two A's. It doesn't work because missing chair counts can be negative counter, and in that case, still I have to traverse also, yeah, chairs. Okay, so instead of this, let me say missing chair counts and also um enough chair count or stock chair count. What I mean by stock is too many or remaining chair count. Yeah. Okay, so that being said, so I will move the right character and current chair is right. So then what I should do is if this is the missing chair count. Oh, and I'd like to make sure that this is a hash map. It's a counter, it can have some chair and with the value 0. But I don't want to make it because I don't want to traverse each key values in the hash map. I just want to say if there is any key or not by just saying the key length. So instead of this, I will use this and or I should just let me do it in this way. I don't know if this works or not, but let me, yeah, amend my code if this doesn't work. So, with that being said, in line 39, if this is a missing characters, I will, missing count as right, then it will equal 1. And then if this becomes 0, which means that I can delete this key. And to count. And otherwise, if But I have to know which chairs are the mat we take care. So let me call it teachers. So this teachers holds every chair which matters. So if the new character is in what we matter, then I will put it in the structure count. Okay. Oh, actually, this can be counted. Okay, so then what you do, so structure count, I put it in the stock, and otherwise, because this chair doesn't matter, I can just forget it. Okay, and what I should do is here, I have to validate if the current wind is valid or not. Yeah, so in this way, I can say if this missing check count is zero, so this isn't valid. So if this is a valid window, I will update the current left and right with. Yeah. Oh, but if I do that, the problem is I have to take a look at every, so for the problem is this part, line 36. So current means sub string, I have to build every substring which is valid every time, so it will take more time. So let me say valid mini range, and I will call it. So let me say should be, you know, let me first make it num first. If this is valid window and if valid mini is num, the valid mini range should be current left to right. And otherwise, oh, so this is valid or current. Okay, let me see. Current main is and current mean length and current. So if current length is smaller than mean length, I will put this one. But let me say, I will do a bit of, refactoring. So instead of doing this mini ranks, let me do it in this way. So in this way, I can put mini ranks is, you know, infinity if it is, if the current wind is, if I haven't found any valid window. Yeah, so, okay, so this is how it works. So in this way, I updated it. So the next thing I have to do is move the left. Oh, wait, so, sorry. So, what I can should, so, no, sorry, I shouldn't do this. What I should do now is if this isn't valid window, I will just return and continue. Otherwise, I have to firstly move left counter as much as possible here. Yeah. So, and what I can do is, oh, I mean, so for this one, oh, I think I still have to make sure structure count. Yeah, okay. So move left as much as possible. What I can say is current is at left is not in. If this isn't in teachers, I can move it. Or if this is in teachers, but there is a stock. So in this case, I can move, yeah, left. So while this is true, I will move the left window. So, and here, so it's there is, I can decrement the structure count. Yeah, so this is the way. Then I will move left. Then in the end, I will update the valid mini range. Yeah. And in the end, I will return the valid window, minimum valid window I finally found. So if valid mini range is none, I will return empty string. Otherwise, I will return. Yeah, substring of S from left index to right index. Okay, let me walk through my code again. So I will think of this example. Maybe this is too wrong, so I will use ABCC and ACC. This is a good example. Yeah, I will do is this. So firstly, teachers should be set of A and C. Then missing chair count. This should be dictionary of counter T. So one A and C one. Then stock should be there's nothing, so it's empty counter. Then I will start with left 0 and I will move right index. So firstly, I move right. So firstly, right is 0. And if S right, which is A, is in missing chairs, yes. So in this case, I will decrement S chairs, yeah, by 1. This is now A0. Then if missing chairs count is equal to 0, I will delete this key. Then I will go to line 62. If rank's missing chair count is 0, it's valid, but there is one key, so this is invalid. So I will continue. Okay, and go back to line 53. Then the right counter should be now index 1. So then in line 59, S right in teachers, yes. So stock chair count right plus equal. Oh, this should be S right plus equal 1. So now I have A1. Yeah. So this isn't still valid window because I have C1, so I will already return. No, continue. And then right is now index 2. So S right is now B. B isn't in missing chair. So I will go to line 62. Then it's valid window. No, so I will just continue. So B is completely ignored this way. And then I will move right again. And S right is now C. And in line 55, S right is in missing chairs count. So in line 56, C will be incremented to 0. And then this should be deleted in line 58 and 59. Then I will go to line 64 is valid window. This is 0, so this is valid window. So I go to line 70. And S left, which is A, is in teachers. And I will go to here, stock chair count S left. Yeah. So A is in the stock. So in line 71, I will go into line 71. And in line 71, because this is in stock, I will decrement by 1. So this becomes now 0. Then I can move left by 1. Yeah. Then in line 77, mini rank says currently valid mini range is none. So this should be infinity, and current rank is right minus left plus 1. So which should be now 4 minus 1 plus 1 is 3. And because current rank is smaller than mini ranks, valid mini range is updated with left and right, which is 1 and 3. And I finish the iteration and go to line 82. And because valid mini range is not known, I will go to line 85 and I will return ABC. Okay, good. So let me run my code. It doesn't work. I have to log in. So wait a minute. I will stop my sharing screen. Okay, so now I'm logged in. So I will run my code. Okay, so in here, this is invalid running. So nothing. Good, this is accepted. So I run my code. Oh, I've got the wrong answer. So if string is AB and T is A, it should return AB. No. It should return only A but it returned AB. The problem is, I guess, here is invalid window at the moment of A. This is judged as invalid, so I already returned here. So what happened to this? So missing check count, that's right. Yeah, this is, I think, quite a simple case. So let me, yeah, print out what's happening here. So what my concern is green, left, right. I will see if for each left and right, is it just as is invalid window or not. Okay, so here 0, 0 is valid window. Oh, so it is just as the right valid window. So it went here and S left, not in T. So what happening here is when 0, 0, somehow, again, let me see here. When the left goes. Oh, so here left is still 0. I'm pretty sure that it stops with 0, 0. Yes. Mm. So in that way, what happened here is current mini ranks should be 0 minus 0 plus minus 1. So this is model, so this should be valid mini range should be 0, 1. No, 0, 0. However, after that, it is updated with 0, 1. Why was it? I guess it's because this equation is wrong. New ranks. Ah, wait. So I I'm updating valid mini range. So I think when valid mini range is updated with 0, 0, then the range should be 1. And for 0, 1, the range should be 1, 2. No, the range should be 2. But centrally it's not working, so compare 1 and infinity. And then 0, 1 is true. Wait, what happening here? So when it becomes AB, this AB is buried, I guess. Ah, sorry, this should be here. Yeah, so current rank is 2, mini ranks is 1. So this buried mini range shouldn't be updated. But somehow, oh, it's not updated. Wait, hmm? So buried mini range is finally, it should be 0, 0, but it returns AB. Ah, sorry. So this should be buried mini range 0 to valid menu range 1. Okay, good. So let me run my code again. Okay, good. Finally, it's accepted. Okay, so let me, yeah, review what my code and just finish. I will finish my day's practice. So today's question, I have to find the minimum window substring. And for that, I use the sliding window. And for sliding window, I move the right pointer and then I shrink the left pointer as much as possible for each right pointer. And the challenge in this question is so to find if the window is valid currently or not. I mean, I wanted to know that quickly. So for that, just keeping track of the window as the number of characters in the string didn't work. Because in that way, I have to take a look at every key in the hash map, I mean the counter, to know it is valid or not. So I ended up using two data structures. First one is missing check counter, and the second is structure count counter. The benefit of using these two data structure is that here in line 65, I could know if there is missing chairs or not in the constant time. Yeah. So in that way, I first remove the right counter and then I push it into missing chair count or stock chair count if there's a chart which matters. Then I could find if it is valid or not immediately. Then in line 70, I move the left pointer. Yeah, so the key at this point is we're moving it. So it's, yeah, I make sure that if that is chair which doesn't matter or some chair which is in the structure counts. Then in line 77, I updated menu range, yeah, which signifies the current smallest substring currently found so far. Yeah. Then I finally return the substring in that window. Good. Okay, let me quickly see the tutorial. So, yeah, code works long enough. Oh, I think it did so. Yeah. So in this tutorial, it uses I don't know what it is it's doing, but yeah. Okay. So yeah, I think the editorial is a bit, I mean, it uses a bit different approach from mine, but yeah. So good. Okay. So I will start finish my today's coding practice. Thank you so much. Bye.